everybody. My name is John Carr. I'm with the Wissahickon Valley Watershed. So I'm going to just do a brief introduction of the project, some of the partners we have, and just the timing of how long we've been working on this. And then Biohabitats with Brad and Joe will get into some more of these specific project details. So get started. You can see it's the Wissahickon Creek Collaborative for Stream Restoration. This is our site, which you will learn a lot more about as we move on. But just wanted to give you a little bird's eye view of what's happening. This is the Wissahickon Creek that you can see that runs through this Pico power line right of way up there. There we go. A little bit about the Wissahickon Valley Watershed. We're a membership-based land trust based out of Ambler, Pennsylvania. We have water quality monitoring that we've been doing for a number of years, since around 2004 in-house. And then also we've started with volunteer water quality monitoring that was talked about a little bit today with these volunteers, creek watchers that get out and monitor sites along the creek. We have preserved over 13,000 acres of land within the Wissahickon watershed. We do restoration projects, education and outreach, have public events, public meetings, all sorts of things to get people informed. And then the Delaware River Watershed Initiative, I'll get into a little bit more, but this really has helped this project to move forward, and that's part of the collaboration with this. There we go. This is just the Wissahickon Creek watershed. You can see it feeds into the Schuylkill down in Philadelphia. This is Fairmount Park, Forbidden Drive down there, and then the whole watershed in general. The main stem of the Wissahickon, and then our project is in the headwaters location, which is in Upper Gwinnett in this section. So a number of years ago, it was around 2010 or so, the watershed started a Wissahickon from the Top campaign initiative that helped to improve water quality in the headwaters area of the Wissahickon. So we did a number of projects up there in this site, including some stream bank restoration along here, a stormwater berm that helped collect water from a subdivision that was built before there was before there was water quality ordinances that were intact. So there was no sort of basin or anything that went with that. Retrofitted some basins, created a wetland, and that sort of thing. So this all happened as part of the watershed's core work since around 2010. And then the Delaware River Watershed Initiative came in, which is a big initiative that looks to improve the water quality of the whole Delaware River. So this helped the watershed to become more engaged with the municipalities, other landowners, and have access to funding for projects with the collaboration effort. So you can see this was talked about a little bit today. It's a huge group that encompasses the whole Delaware River Basin, and it's broken up into 8 different clusters. And this is the upstream suburban Philadelphia cluster, which is the cluster the Wissahickon Valley Watershed is a part of. You can see the different watersheds that are involved, and then here's our Wissahickon right there. Within each cluster, there were certain protection priority project locations that were highlighted, and in the Wissahickon for this was the headwaters area, and then also parts of the Sandy Run, which is a main tributary to the Wissahickon. So this project that we're talking about today fits into the priority project for the William Penn Foundation in the Delaware River Watershed Initiative. This is just another aerial just to give you kind of the development and what the site looks like. You can see it's got the city in there, and then it's all suburban development up above. So a lot of housing, a lot of stormwater runoff, a lot of issues within the creek. Wissahickon Watershed, this is just now zoomed into the top, that headwaters area that I was talking about. This is our stream reach that we're working on to improve. And then the rest, you can see we're at close to the top of the watershed. An important thing with this and the William Penn Foundation Delaware River Initiative is cluster of projects to help improve the water quality. So ours, large one, obviously right here we're getting into more detail. Upper Gwinnett, a local municipality, has done a lot of work along the Dodgeworth Run, which is a tributary here, to help mitigate some of the stormwater from North Wales. So they put in 3 additional detention basins that really captured all this extra runoff. That's directly upstream of the project site, which is really important. Also Merck, which is a local company, huge, all up in here, has been a partner on this project. They, along with giving us access to the site, also helped by donating about a 10-acre parcel along the Wissahickon, so further that stream buffer. So you can see just another little brief outline, and now background. So you can see some pictures here. The Wissahickon runs right parallel to this Pico right-of-way parcel of land. It's the start of our Wissahickon Green Ribbon Trail, which is a trail that runs the whole Wissahickon Creek. So public access is there. It was ag land in the past, and as we mentioned before, a lot of single families, detached homes, stormwater runoff in the watershed. Within this project, we have these main goals that we wanted to obtain by our project design. Stable stream bank, reduce the sedimentation, reconnect the stream with the floodplain, which you'll see this is the main project goal that we're going to do, and this will help to reduce some of the others, and then improve the hydraulic capacity. An interesting thing, so you can see this would be a typical sort of floodplain forest and all that. Being under a Pico right-of-way project, we're limited on what we can plant and put along the buffer because of the power lines above. So there's a lot of working back and forth with them on coming up with the exact design. And then this is just everybody who's been a part of the project. There's Wissahickon Valley Watershed. We've been doing this since about, I think 2010 or 11, the project came to thought. So it's been a long process moving forward. Obviously Upper Gwinnett Township, the local municipality there, needs to support this and be a part of it, and also work on their TMDL requirements upstream, which has helped to improve the water quality. Pico, the landowner, Merck, the local company right there that will give us access to the property. We have National Fish and Wildlife and PA Growing Greener who helped to fund some of the project, so a lot of people involved. Temple University, we heard a lot about water quality monitoring this morning. They are monitoring the site upstream and below before the project has been completed, and will do again after. So that gives us some of that data on what's happening with the restoration project. And then of course Biohabitats, who is our consultant and working to design all this. We have to pick the right people to do the job. We've worked with them in the past on stream restoration, and it's been pretty amazing the work that they do. So getting all these people together, having a good group is the best way to go about getting a project started. So now I'm going to turn it over to the experts who will go over the process and everything and the actual project. So Joe Berg here.
Thanks, John.
Yep. You saw what I was doing.
Yeah, I'm hoping I have as much success as you have.
That tripped me up in the last presentation. I was like, why does it keep changing? No one told
And
me
I
that
keep
was
touching
smart.
it, and it starts doing other things. So we heard this morning about stream restoration and just a little bit. But one of the interesting points that I wanted to develop a little bit more was this idea of you can't expect stream restoration to solve 99.9% of the watershed's problems. And the reality is USGS soil fingerprinting has shown that in an agricultural watershed, as much as 50% of the contaminants of the sediment, the nitrogen and phosphorus that are coming out of the watershed are coming from stream channel erosion and adjustment. So the stream channel repairs aren't fixing 99.9% of the problem, but they're fixing in an area that's primarily agricultural, they're fixing 50%. In an urban or suburban area, 75 to 95% of the problem is, in terms of sediment, nitrogen, and phosphorus, is from stream channel erosion, not from material coming off of the streets getting into the streams. Although from oil and grease and heavy metals, there's some other issues. Really, the biggest problem with our watershed is the volume of water that's being delivered to our streams. And that's what's driving This is a photograph in Cobb's Creek in Philadelphia, Fairmount Park. And you know, this is 6 foot of channel incision from a little tiny headwater drainage area. For the Wissahickon project, we're talking about 4 square mile drainage area. For this, we're talking about an 1.5 acres of drainage area. So, you know, that stormwater can do a lot of work on the stream. So just to reinforce that, this urbanization, suburbanization can, you know, if it starts at the top, it's eroding material, and that material is moving downstream, but it's not being carried all the way downstream. It's settling out when that precipitation event tails off, that material falls in the stream channel. The next precipitation event happens, you have a flush of water coming into it, it sees that sediment that's already accumulated in the bottom of the stream, and it's easier for it to go around that than it is to pick it up and transport it. So it goes around that. It tends to cause stream channel widening, which is more erosion. You know, when it's eroding a steep bank like that last photograph, it has gravity helping it. That sediment is falling into the water and being transported downstream. So the idea is it keeps getting worse and worse as you progress downstream. And the last presentation that I was in was that sort of groundwater discussion. And the idea there was this groundwater is a really important resource. And when we start converting our landscapes into hardened surfaces and shedding that water, and we do have a net increase in discharge. It doesn't matter how good our stormwater management is, doesn't matter how good our bioretention facilities are, they're designed to improve that peak attenuation or to improve the water quality, but not to reduce the volume of water. I mean, there's some techniques like infiltration systems that are designed to reduce the total volume of water that runs off. But for the most part, they're a really small part of the active best management practices. Most of the best management practices are either peak attenuation, like a detention or a retention facility, or their water quality in the case of like a bioretention facility with drains. So what ends up happening is we have these increased energies, we have an enlargement of the channel, and to the groundwater perspective, that's acting like an agricultural drain, lowering that water surface, the groundwater surface, allowing that material to export, allowing more air in the soil, which allows faster microbial remineralization. So what that means is because the bugs have more air, the microbes and the fungus have more air in the soil because the soil is not filled with water, they can accelerate the loss of that overwinter leaf mat that's on the forest floor. So that stuff is no longer like, you know, it used to be that you could go into the woods and find like a foot of this organic sponge. So when it rains, that soaks up the water. Well, that material is gone because we've lowered the groundwater table. We've allowed the things that live in that saturated media to respire more quickly, to have higher metabolic rates. So they're chewing that material up faster. So we have a loss. Larger channels, reduced fish habitat. Nothing good is happening. This is sort of elementary, but just again, under scenario A, that's the pre-development condition. You know, it rains, it takes a certain size precipitation event to generate this runoff curve. Then you build something on it, and you get much more runoff. And not only that, but you get more frequent runoff, because what used to soak into that layer of organic material in the woodlands now is all shed. It's all running off. So then we fix it, in theory, with bioretention, with detention facilities or retention facilities. So we don't have that same peak, which causes a lot of erosion problems. But erosion is a function of the velocity of the water, the volume of the water, and the time of elevated flows. So we've taken this down by extending the duration of flow. So there's a longer period of time that the water is working on its channel, doing more work, which is erosion. So the current situation really doesn't solve the problem. So that's just a summary here of, some of the same issues. And in the background, you see a couple of headwater systems that are receiving runoff from urban areas. Some of them piped, some of them just natural surface concentration of flow from folks' backyards. So this would be your typical bankful discharge. There's a small storm event, maybe a 2-inch rain, and that's what the stream channel looks like. It's not quite out onto the floodplain, which is really well adapted to handle that water. Instead, it's all in the stream channel. And while it's in the stream channel, the theory for a bankful discharge is it's a channel-forming discharge. So what's happening is it's forming that channel. It's eroding that channel at this period of time. You've got the maximum depth of water, the maximum volume of water to the smallest possible area of land. Not a good recipe. This is what that stream looks like afterwards. This is the other 345 days a year. Not much habitat for fish. It's, you've lowered the groundwater table, so that forest is, getting invaded by multiflora rose in this condition. But the point is that running all that water through the stream channels sort of not the way to go. So how can we fix that? All right. Getting back to the Wissahickon project goals, it's about reconnecting the stream and those stormwater flows to a larger surface area, the floodplain. The floodplain's a regulated feature. You can't go in there and build in it. We shouldn't. And then, secondary is to create a stream system that is relatively stable in its location. Because what we don't want to do is have that thing moving all over the place, exporting a lot of sediment downstream, sort of causing that downstream erosion at this higher and higher rate like we're talking about. So the theory is, in this project, Watershed, the streams are stormwater dominated. It doesn't, you don't have a base flow, even though it's got this fairly large drainage area. There are parts of it that look like a little driveway. It's a nicely sorted, gravel to cobble bed. There's nothing there. There's no pools. There's no riffles. It just looks like a driveway. If we can bring those up, and there's a large floodplain associated with this project area, as you'll see in additional photographs. If we can get that stream to be reconnected to that floodplain, all good things happen. You have an actual reduction in the total volume of water that's leaving the site because it gets up on the floodplain, it soaks into the soil. You have little depressions where the water sets for an extended period of time. Maybe those places become vernal pools, hopefully. And then even on larger events, when that amount of water that you're losing into the floodplain soil is not really significant as a part of the larger storm event, you're still getting this tremendous reduction in stream power, because for the stream to get through that area, instead of building depth, which increases shear in a geometric fashion, it's not exponential, but a foot of additional depth dramatically increases the shear in the stream channel. So by not letting depth build and instead forcing it to flow out in a wide, shallow flow across the floodplain, you've got sediment trapping, you've got plants being able to be in contact with that water, slowing it down, maybe taking some of the nutrients out of it. So that's one of the reasons why stream restoration is really sort of standing up as the most cost-effective and the most desired BMP. Again, it takes work up in the watershed with source control, reduction in impervious surfaces, smarter building, smarter development planning, but this is where most of the counties the feds and the state have realized the biggest bang for the buck. Stream restoration delivers the most value for the smallest incremental cost. And really just to sort of reinforce the notion that our floodplains aren't just pains that we have to work around, and they are pains that we have to work around, but they're ecosystems that deliver a lot of values of importance to society as well as to wildlife, to nutrient uptake, just the idea that connection between the surface water, the stormwater for the most part, and the underlying soils, as well as the plants. And the last presentation, I don't know how many folks were in the groundwater presentation. Nobody? Yeah, a few, okay. What ends up happening is you saturate that floodplain soil under high flow conditions, and then you turn off that hydrograph because it's a developed watershed. It doesn't have constant base flow. That saturated floodplain, the water just sort of works its way down and back into the stream. So we've actually seen some stream restoration projects that we've been involved with where prior to restoration they were ephemeral. They only had water when it rained, were intermittent, where they were dry all summer long. We've seen those stream restoration projects push the hydrologic regime of those systems to be perennial streams, where they now flow 365 days a year for years after restoration. So, that's not always possible. It has a lot to do with the drainage area. It has a lot to do with the size of the stream. But that's sort of one of the values, perhaps the predominant value of floodplain reconnection. Now, turn it over to Brett.
Morning, everybody. I'm still a little froggy from a cold, but I'll do my best. I'm going to follow up with Joe's section on, why stream restoration and some of our approaches with how those approaches apply specifically to this project. So, here's a picture of the current stream condition out there. When Joe mentioned that sort of access road look to some of the stream channel there. This section is actually immediately upstream of the project reach. But you can see, we got dug here for scale. We're looking at maybe a 40-foot channel width. And this tape is stretched from top of bank to top of bank when we were surveying our cross section. Doug's a good 5.5 feet tall.
Oh, you'd be insulted at that. He's got to be 6.5 foot if he's.
And so, there might be 8 feet there. And, this is a classic example of what we call the over-widening in the incised channel condition. And that really leads to, even during really high flows like your 25-year storms or, events that don't occur that frequently are still trapped a lot of times in that channel. And that just means all that energy is trapped in that channel and chewing it up. And we're seeing that at our site. So some other things we're dealing with throughout our project design that I'll dig into a lot more, but I'll show you some photos of existing condition. Here's Chris Rehack, our GIS expert out surveying PICO utility poles. And there's a ton on this site. It's a utility right away with both transmission towers, the really tall metal towers, as well as a ton of distribution lines, which are the smaller wood poles. And this one in particular, and there's a handful just like it, as the stream has migrated laterally and is actually threatening those pools, and some of them would come down over time, and that's something we're going to look at as part of we have looked at as part of our restoration design. And here's just another kind of shot up the floodplain of the power utility infrastructure, but also just that it's a utility right away, so they mow that every once in a while. They've actually let some of the tree and shrub grow up immediately on the stream channel, but in general, once anything starts getting too large, it has to come down, particularly under the towers. They don't want anything growing under those. Oh, and we also have a sewer line on the northern edge of the stream. Urban stream restoration are always dealing with water lines, sewer lines, utilities. You know, it's usually not as easy as having a blank slate and be able to put a nice sinuous stream channel in place. I feel like our geometry is driven by this stuff more than anything else. And also the intermittent flow. Just keeping an eye on time here. This is, you know, like you mentioned, a 4 square mile watershed. I've never seen a 4 square mile watershed with intermittent flow. I'm not exactly sure what's causing it. Probably some of those urbanization problems, might be some water withdrawals. Sure, it has something to do with the geology, but you know, when we were out there doing our first stream assessment, it was pretty much bone dry, except for a few sort of puddles in the stream channel that actually had some fish trapped in them. And then every other time I've been out there, outside of that late summer, early fall, there has been flow. So we got an intermittent situation. I think you know, at the very bottom end of our project reach, it becomes perennial. I think we have some days migrating in and out based on available flow. I don't know if this one project reach is going to do it, but it would be great to see water in that channel year round. So we actually assessed a much larger reach as the first phase of this project. I will say that the design and permitting reach right now is just this reach 1, but we looked at a larger, maybe a little over a mile reach all through this Pico right away. And we were looking, during our initial assessment, looking for things that were going to drive our project design, like floodplains. Floodplains are always a major consideration in our stream restoration project. We did what's called a bank erosion hazard index along the entire stream channel. It's looking from extreme bank erosion condition to very low. We had a mix, but I'd say the average was probably a high to very high. And that's driven by a few things like the bank slope. The more vertical it is, the more prone to erosion. If there's any vegetation on the bank or it's just bare soil. A few other things, but we had, you know, in our project reach, typically on the outside bends, we had those bare eroded soil slopes that we want to deal with as part of this project. All these red dots are Pico power pools or towers. So, you know, they're not just on the edge, but they're mixed throughout and back and forth on the stream channel. So we got to make sure we fit through them with our design. And we also did a tree survey, and we had a ranking, a tree preservation priority from low to high based on species, condition, age, or size. You know, typically you'll have to take down a few trees when you do a stream restoration, particularly if they're already undermined and eroded. But, you know, in our project reach here, we had a little group of decent quality trees, maybe down here. If we don't have to take those, we don't want to, because they could be 50, 100 years old and providing a lot of benefits that can make a minor adjustment. We'll try to save them. Oh, and also here's our sewer line that I mentioned. So yeah, there's just a more zoomed in of our project reach with these 2 power lines running down through and some of these high quality trees. So what was our restoration approach based on some of those goals we talked about earlier? we decided that we wanted to try to get the water out on the floodplain sooner. And we wanted to create this relatively level floodplain bench outside of the stream channel that water could break out onto and soak into. And we were also going to put some, think of them as little maybe pocket wetlands or vernal pools, just depressions in the floodplain that could hold the water a little after the storm. I don't know if it's going to infiltrate in the floodplain, but evapotranspire and create, temporary ponding and maybe add to that base flow a little bit. So to get the water out of that floodplain, we were going to do a couple things. We were going to shave off some of that floodplain, and I'll get into that more in a little bit. And we were also going to add some riffle structures to the floodplain. So think of it as meeting that floodplain halfway, one with the riffle structures in the channel and then the shaving on the floodplain. We were going to improve that channel alignment to make sure we weren't threatening those pico pools or those sewer lines. And also there was, we call them tortuous meander bends. There's meander bends that almost came back on themselves. And that's occurs sometimes in unstable systems, so we wanted to try to smooth those transitions. Reduction in bank slope. I talked about the B-high, the more vertical, the less vegetation, the more prone to erosion. We are typically steeper than 1-to-1 slopes here. We want to really lay those out flat, maybe like a 10-to-1 slope or 6-to-1 when we had some kind of constraint. And also we wanted to get in more native plantings where we could. A lot of this grass out on this site, not completely covered with invasives. It was not the worst place I've ever seen, but we wanted to try to enhance. Here's a little image that shows generally our approach. So this is our existing channel, over widened, down low. We're talking about putting in a new channel. It's a little smaller, a little higher, reconnects to the floodplain a little faster. And here's those, those benches. And then eventually at the edge of the bench, we'll have to tie back up to existing grade.
This is the red line, the existing condition?
Yes. Yeah. Yep.
Including bank.
So we developed a concept alternative for that entire mile reach, but I'll zoom back into where we're at right now. But I guess in general, I wanted to show here these darker green areas in the floodplain. Kind of think of that as that lowered flat area that the water can get out to quicker. And some of these hatched areas would be our floodplain depressions. We could fit them in wherever we could on that flattened floodplain area. And but we preserve some things like some high quality groves of trees, or we have to not grade around the pico pools. They actually had a 40-foot grading buffer. They handed me this standard requirements for working in there right away at the beginning of the project. And I said, well, the stream is 1 foot from some of your power pools, so I can't abide by that 40-foot buffer. So I told them where I could, we'd have a 20-foot buffer, our work from their pools, but where we couldn't because it was right there, they said, well, you're doing us some favors by moving the stream away from some of our threatened infrastructure, so we'll let that one go. So zooming in specifically to our project reach, kind of section by section, we're going to construct a lower flow channel. And what I mean by that is, so we run hydrology and hydraulics as part of our project. And in our existing hydrology, we might show that existing entrenched channel carries the 10-year storm. or the 2-year storm. I can't remember exactly on this, but we said we don't want our proposed condition to carry that much water. We want it to fill up quicker and break out during more frequent rain events. So here we ended up going with a 1-inch storm. We designed our channel to carry that, and anything over a 1-inch storm would get out under our floodplain. And Joe might even like when it gets out even sooner, but
Yeah, because, so 95% of the annual precipitation events generate less than 1 inch of water. So the idea is the smaller that stream channel is, the more frequently those small storms, the safe storms, are out on the floodplain. If we had our druthers, a 10th inch precipitation event would kick water out onto the floodplain for the floodplain to work on it. But we have
It's a balance.
floodplain restrictions here because of local property, adjacent property owners, and even just federal regulations about raising floodplain elevation. So we have to sort of mix and match, like Brett's talking about.
But, you know, the status quo is what they call bankable event, which is usually somewhere between a 1 and 2-year storm, which might be more like 3 inches. So, you know, we're beating that. We're going to get out onto the floodplain a few times a year.
I see you have floodplain depressants. Will you be installing them to catch those wind storms?
Yes. So, you know, this design channel to carry this 1-inch storm, it's about 25, 30 feet wide, and it's 1 foot depth at the riffles.
As opposed to this 40 by 8 foot.
Right. And so these darker green areas are going to be that relatively flat graded area around the channel now. And then within those flats, typically in the meander bends, are going to be these 6-inch deep depressions that we're going to put some wetland plantings in. And so, yeah, the thought is when it gets out of bank, it's going to get out onto that floodplain. It's going to fill these depressions, stay afterwards, help to develop some floodplain wetlands. And then all these lighter green areas are just that real gradual tie back up to existing grade. So there is a fair amount of excavation that is going to go into creating this, which I'll talk about a little bit. Originally, we were thinking about, on these outside meander bends, which are currently eroded, installing some rock toe protection. But we found that this stream reach has such a low slope. It's like it's like a 0.5% slope, which is extremely low. It's flat out there. And with our new restoration approach, it takes kind of the velocity and shear off of this channel so much that we really didn't feel that we needed a lot of rock protection. The only place we ended up installing it was this last meander bend, which is the worst area. And it's also, with any restoration, you have to tie in upstream and you have to tie in downstream. It's always bane of our existence sometimes. So, you know, up here we can bring up the channel and get the water out fast, but down at the end we got to tie back down. So, you know, that the channel starts getting deeper and entrenched again as we tie back in. How am I doing on time? Okay. I'll talk for another 10 or 15 and we'll do questions. So I'm going to step through some of the project-specific considerations and talk about our partners. You know, we did sell this presentation as a collaboration with our partners, and there's been a lot of it. So we'll talk about PICO a little more, the water and utility coordination, the floodplains, floodway, construction access, and some of the trees, habitat, fisheries issues. So, you know, PICO was key here. It's a majority of their property. Wissahickon Valley has a little parcel, and Merck has the access area and a little of the stream. But we had to get PICO on board. So one, we had to protect their infrastructure, and I talked about, you know, realigning the channel to avoid the pools where we could. But we also had to ensure they still had access after our project was done. So, you know, for instance, I thought about, I don't really like this meander bend. It's even worse in the existing condition, but maybe I could go around that. But then I thought, Pico, you know, comes in certain directions to their pools now. I don't want to change how they get to their pools. You know, we put this wetland here, but I said I still have to make sure they have a way to get in and out because they have to maintain this stuff. You know, when I had the grading buffer here, you know, for 20 feet outside of that pool, I didn't do anything, but I lowered below that. So I changed the slope around these. So I had to make sure I had a drivable slope back up to those pools at a 10-to-1 slope. So, you know, I had to consider the existing land use and then plantings with Pico. They gave me a little guidance and we ended up coming to essentially an agreement that we wouldn't plant any woody plants. Actually, let me jump around a little bit. Under the large metal towers, transmission towers, we wouldn't even plant shrubs. It would be an all herbaceous under there, because if they wanted to mow it, they could. Under the distribution lines at the wood pools, we could plant low shrubs, I think under 15 feet. And then when we didn't have any conflicts, we could plant trees, and that ended up being a really small area. I realized today I forgot to put a planting sheet in the plan set, but we made a special set for Pico for their project review, and this is just to show you all these are different power lines going over our site. So, and if you can see these little bit larger letters in the line style, that's the distribution line. So right over the center of the channel here, so that's a no woody plant zone. Now you can see the little bit smaller line style here or here, that's distribution line, we can plant shrubs. And so one area I know we planted trees is like this outside bend, because for once we're not under, you know, power lines. So. But you can still, you know, you can use native herbaceous plant mixes. It could be really nice wet meadow area without even having woodies. I mean, there's not many woody plants out there now, so. One other thing. The clean fill requirements. John and I are dealing with this now. So we're doing this large floodplain excavation that I'll talk a little bit more about in the floodplain section, but we're removing essentially 6,000 cubic yards of material, soil from the floodplain. That's a lot of dump trucks. And Pico has requirements that any fill that comes onto their site or any fill that goes off of their site has to be tested for clean fill requirements. There's nothing out there now that leads us to believe we're going to have a hit with some kind of toxic chemical, either regulated fill or hazardous waste in the floodplain, but they said you got to do this, and it wasn't, we didn't have it in our original project plan or budget, but we're adapting and we're going to make it work.
So are you bringing fill in or using the fill that you're excavating?
Yeah, the only material we're bringing in is rock, essentially, for the riffles.
Do you test the fill that you take out of the creek before you put it back in again?
No, so that like 6,000 yards that we're going to excavate and then essentially take to a quarry or a landfill or some site that'll take the fill material. Pico wants us to prove that material we're removing is clean before we give it to somebody else. So we're doing that testing now. And, you know, just some, they give you certain requirements that we sort through. Some of the things we talked them out of, like installing a permanent access drive along the creek, but some others, you know, you have to do. So we met with, I guess, Upper Gwynedd Township for the sewer in North Wales Water Authority for, you know, to talk about if our project was going to impact their water and sewer lines. They were both great and willing to work with us, but they did say a few things like don't plant any trees on top of our lines and give us the 10-foot buffer. And we kind of got out in front of, we said, well, if we know we're going to be running dump trucks over any of your water sewer lines, we'll put what's called a hardwood construction mat over top of it just to distribute the loads. So that one was relatively easy on this project. I guess I just included this to show the water and sewer lines. And so the existing bank is pretty much vertical right here. And we may have kind of graded back a little further this way, but we didn't because we had the water lines there. So we kind of pushed the stream down this direction with that more gradual slope. Okay, floodplain and floodway. FEMA has a detailed study in this area. It's pretty old, but FEMA studies there. That means people in the area are paying for flood insurance if they're in this studied floodplain. And it's not just a detailed study, it has what's called a floodway. And a floodway is as close as you can get to like a no development zone in the FEMA world. And they essentially say that no increase in that 100-year floodplain or floodway is allowed in this area. And, you know, when we talk about reconnecting the floodplain, you know, the easiest way is to just fill up the channel and kick the water back out onto the floodplain. In some areas we can do that because we're not affecting anybody. But here, we couldn't do that. We had to reconnect the floodplain, but still not increase the 100-year water surface elevation. So that's where we end up with all that cut material. You know, we can bring up the channel about halfway, but then we have to cut out a lot of that because, you know, the basic, you know, rule in hydraulics is Q equals VA, flow equals velocity times area. And that cutting the floodplain and filling is that balance of the cross-sectional area. So here's just a quick look at the FEMA floodplain. This is our project reach right here. Might have to squint a little here, but this is our HEC-RAS modeling for the project. And this is how we prove to the regulators that we're not increasing that floodplain elevation. So the pink line is our proposed condition at a riffle. And then this black line is the existing condition at a riffle. You can see the existing has this, you know, relatively deep incised channel, and then in our proposed, it's a more gradual section. It's up a little higher. We shaved off a portion of the floodplain here. So in summary, you know, what we filled in here, you know, that's fill area. We cut here, and that made sure that we didn't increase that flood elevation. So the blue line is the existing 100-year flood, and the pink line is the proposed. So we've actually, with this project, lowered it an average of maybe a quarter of a foot. We've lowered that 100-year. And this is similar thing on the proposed condition at a pool section with one of these floodplain depressions. You know, in the pools, we only raised up the channel a little bit because they're a little deeper, but we shaved a lot of this area to create that flat that the floodwater can break out onto, and then, you know, pond in that depressed area a little bit. So 10 minutes, okay. Merck was adjacent on the north side to our property. And I don't think we, Mark didn't even really have any requirements for us. It was just doing the paperwork, with them to make sure we had the agreement in place to access. And there's a nice driveway apron off of Moore Boulevard here, and they're gonna be nice. They're gonna let us install a rock construction entrance and then an access road down to the channel. Hopefully it's not that much of a beast, but so trees, wildlife, and fish. We're gonna do a few things to enhance the project, like we're gonna install some habitat boxes, bat boxes, mallard boxes, just little things that will help, the wildlife, but also the community likes to see them too. It's a big selling point. We're gonna do some things like protect the trees, where we have a really nice tree in our construction area with either fence or planks. Little things like we can do for the fish. We have in our sequence, clear the channel of all fish before you start to pump around, maybe just with a net quickly. I wish I could show you some construction pictures maybe next year, but we're not quite there yet. We're doing a design build approach, which I'll sell real quickly. It's a way you can avoid kind of the sometimes arduous bidding process if you have a design contractor and a construction contractor that you trust, or even somebody who can do both, and they're qualified. You can smoothly take it from design through construction. If you do bid it out, I recommend you get some pre-qualified construction contractors, because this kind of work specialized. You don't want just anybody doing it. E&S approach, we're gonna pump around, or we're gonna work in a dry channel if it's that time of year. And it's not always pretty during construction, but usually ends up pretty nice. But yeah, we're moving a lot of material, so there's gonna be some heavy equipment out there. And here's a pump around. Restoration after construction. Here's a couple of our projects after a growing season or two. We'll imagine we'll have to do some monitoring for our Army Corps permit on this project. And then make sure we reserve a little time for questions. Anybody have any questions for myself or Joe or John?
It's an obvious one. I stepped in 2 minutes late, but what is the funding source for this project?
Yeah, there's multiple funding sources. As part of the Delaware River Watershed Initiative, it was a protection priority area for projects. So we got some NIFWA funding and Growing Greener to match those projects.
Do you have a long-term maintenance plan or anything for this? I mean, I've seen a lot of these things go in and get overgrown with some invasive or something, so is there anything you have to do to maintain it?
That's a good question. I mean, the general stream restoration itself, the hope is it's fairly self-maintaining, but things like plan establishment, I agree, that can be a critical period. Typically, the Corps will put in, the Army Corps engineer and their permit will put a requirement that 85% of your plantings need to survive, and that you should, if there's any invasive species on the site, that they should be removed. And that's usually a 3 to 5.
Yes. Sometimes they'll say no more than 10% of the area can be vegetated with non-native species. So you can't have a big stand of something come out there.
Yes, you're probably never going to get every single one, but
Well, has PICO committed to maintaining that herbaceous area in full sun? I mean, it seems like that's, I can picture them coming down for 5 years and just mowing it all down.
I could take that one. We worked with PICO a number of years ago on this site it used to just be full turf grass that they would mow consistently. And we worked with them to put in a warm season meadow that they manage as that now. And they've changed their vegetation management a little bit over the years. Directly upstream of this, if you look at the site, they're keeping silky dogwood, some other native vegetation within there, so they're training their staff to be a little less gung-ho when they go out there and just cut and spray everything. So, yeah, we have a relationship with Pico over the years from that, and we'll just continue that moving on.
And the sort of reinforcing scenario is it's less expensive for them to maintain it the way that they're maintaining it now than the way they used to maintain it. So they're motivated to mow it less frequently.
I guess kind of going back to the basics of, forcing water out onto the floodplain, is there anything that, whatever city or town or municipality can do instead of just having one big culvert dumping all of their, wastewater or runoff into a single point on the stream and, contributing largely to the flow there? Is there any way that you've seen municipalities distribute how they release the water into the environment so that, it's just entering the flow from a different area? Like, would that also be considered expanding the floodplain because you have water flowing in from another
I
place?
might have a good take on that. Dealing with outfalls.
Yeah, it's like we heard this morning, it takes work at every level, all up and down the system. So, unfortunately, most of this watershed was developed before we were as sophisticated as we are today. And going back in to retrofit those things is usually not the highest on local government's priority list. But there is this, green infrastructure discussion, and so I think as communities are faced with new opportunities, whether it's redeveloping underperforming land areas, they start to incorporate that, different kind of paving, different kind of stormwater planning, which all are going in the right direction. But I don't think you'll see, these property owners can become more sophisticated and start putting rain barrels on their property or converting their paved driveway, which drains out onto the road, into pavers or a little speed bump that directs the water off into the front yard, into a little depressional feature like a rain garden. It's a whole sort of social scenario that has to be engaged.
It seems like this is much more, efficient as far as.
And what I was trying to bait Joe into talking about was what's called regenerative stormwater conveyance. It's kind of a new way of doing it, and I don't know if you've been talking about like stormwater outfalls directly to a channel. It's another approach where you can kind of create a step pull system at the lower end of that outfall and fill up that channel with like some sand and wood, like shredded wood chips mix to help kind of soak the water into that matrix and dissipate the energy before discharging directly. So that's a technique to check out.
What's your main source of funding for this project? State grants or William Penn Foundation? What's your source of funding?
The whole initiative was William Penn Foundation. They started it, and then it's the National Fish and Wildlife Foundation funded some of it through a grant program, and then the state DEP through Growing Green.
Who actually is the project sponsor? Was it PICO?
The Wissahickon Valley Watershed.
Oh, Wissahickon Valley Watershed,
Yep.
okay. I think I forgot that.
A few years back, Wissahickon did addressing your question about, outfalls. Wissahickon did a stormwater berm just downstream for the site. There was a neighborhood that had no basin. It was built before basins, and they put up this berm that caught the water coming out of that pipe and let it seep through the berm and down into the groundwater. So there are ways of kind of fitting these things in, but it's not inexpensive. But you get a lot of water quality benefits from doing it that way.
And each site's different and everything, you got to always take into different accounts when you're dealing with sort of these issues.
And the construction schedule, is all going to happen this construction season?
I think it's probably about 6 months of active work. I guess we don't have a trout stock fishery or a wild trout fishery. I don't really expect any in-stream work restrictions. Certainly better. If I had my druthers, we'd build it in the summer and fall when it was relatively dry, and then be ready for the fall planting season. Or, maybe wait for the spring planting season to put the plants in if we get pushed out that far.
What's the time element involved? I know you mentioned, you say it started in 2010. Is there any completion date involved?
I mean, all of our permits are in right now, so I expect to have those in hand probably by the summer. But that would put us into, I can't remember exact dates, but maybe 18 months from formal concept design that I showed you all today to getting our permits in hand. I think I went ballpark there.
Yeah, around 2000.
Yeah, we did.
18 months for planning and design.
Yeah, we did have several months in there when we were back and forth with PICO, just to make sure they signed off on everything before we submitted for permits.
Working with PICO, we had to go through like 7 different departments to get approval because they have a lot of different people who work on their power line sites, so it took a while to get it through them internally.
So it's not unusual for a project like this to have like a 2-year timeline from initial site assessment and developing an acceptable concept through permitting to construction. And then you have 5 years of follow-on monitoring to make sure that it's doing what it's supposed to be doing, as far as the Corps of Engineers is concerned.
Yeah, they take a time commitment, that's for sure. All right.
Can you tell us about how many acres the whole thing covers and what the total cost of the whole project is?
I can talk cost, right?
Yeah, and we're still gonna figure that out a little bit.
Is that a ballpark figure already?
Yeah, I mean, everything together might be $1 million, but we'll see. As far as, what was your first question?
The acreage, size of it, total area.
Because we're doing this floodplain restoration approach, we really expanded our disturbance outside of just that channel. So we're probably about 5 to 5.5 acres of disturbance to do that floodplain reconnection.
And when I was talking about how a lot of the municipalities are going to stream restoration as a cost-effective approach, even at that budget of $1 million or plus, when you start looking at the pounds of sediment removed, nitrogen and phosphorus, it tends to be an order of magnitude lower or a multiple, like 10% or 50% of what it costs to get those same nutrient reductions with stormwater management pond retrofits or bioretention or grass swales or infiltration phases. So an order of magnitude or a multiple more cost effective than any other BMP other than like fixing broken sewers or picking up dog doo. They're the most cost effective ways to improve water quality, cross connections and just litter control. But then stream restoration comes up as the next most cost effective.
All right. Thanks, everybody.